that describe a population or a sample of a study that we are basically trying to disseminate or get people to understand what we're talking about. With descriptive statistics, a lot of times we call these non-parametric type of statistics. And what we're going to do is we're going to actually describe. We're going to say that people in this study have 3 years of college, they come from single parents, their socioeconomic status is within the middle class. You know, there's lots of things we can do to describe the population of people that we're studying. Hair color, eye color, national origin, socioeconomic status, height, weight, age. There's lots of things that we can do, and we usually use those when we talk about descriptive statistics. We're trying to describe the data and what the data is telling us. A lot of times we use pie charts, we use histograms. You'll be constructing a histogram for one of your homework assignments in here, which is pretty neat. And another thing I'm going to do, that research paper proposal, I think I'm going to revise that. I've been talking to the other statistic instructors, and we all want to be pretty consistent with what we do. So I think we're going to do a portfolio, and what I want to do with the portfolio is all your homework, we're going to do an electronic file, and you'll just keep a copy of all the homework that you submit, and then you turn that in at the end of the term, and that's going to be your portfolio. I think that's going to be a little easier to deal with than writing a mini proposal. So I just had to come up with something I didn't really know, since this is the first time I'm teaching this particular class here at this particular institution. I have taught statistics for Webster University in their business program in Arkansas. I taught graduate statistics at the University of Arkansas at Little Rock, and for the past 10 years I've been teaching statistics and research at Langston University in Tulsa in their graduate counseling program. And I've taught statistics here before too. So back to this, I've got inferential statistics. And inferential is just a fancy word for making inferences or predictions. I'm going to actually start predicting. I'm going to predict the future. And I don't have a crystal ball or anything like that, but this is the best crystal ball I've got, is inferential statistics. So inferential statistics consist of generalizing. Remember I said that word generalizing? I'm going to take the information that I get from a sample and I'm going to generalize it to a bigger population. So I'm going to generalize from samples to populations. I'm going to perform estimates, and an estimate would be a prediction. And a hypothesis, which would be an actual educated guess. And I'm going to actually test my hypothesis with a series of statistical procedures. And then I can determine the relationship among these variables. And if I'm looking at just relationships, I'm probably going to use something called a correlational study. So a correlational study is going to look at a relationship and how strong that relationship is between two variables. And I'm not looking for cause and effect necessarily with that. I'm just looking for a relationship and how strong that relationship is. And then, of course, making a prediction about future events, behaviors, things like that. So as we can see, we have data. We're collecting data. We're dealing with data. Like it could be categorical data. And when I'm talking about categorical data, we're talking about qualitative data in nature, like eye color, hair color, religion, socioeconomic status, lower class, middle class, upper class, things like that. And then now we've got quantitative. We're going to be dealing more with quantitative concepts in this class, and they're going to be numerical. So we're going to be dealing with real numbers. They can be ranked. So when we're talking about qualitative in nature, probably not really going to be ranking things so much. We can rank some qualitative data. Like if I have a preference in soda or something like that, and you got these cans of soda, we're going to give them names: root beer, Dr. Pepper, Pepsi, and Coke. My preference, I'm going to rank those. It's still categorical data, but I'm going to rank root beer here is number 1, Dr. Pepper number 2, Coke number 3, and Pepsi number 4, based on my preference. And we do that in society. We take surveys, and people, say, oh, I like this better than this other thing. So we're going to categorize things, and then we can rank them and things like that. We can also do that with quantitative data as well. We can rank it, and it can be discrete. Like I said, discrete, I used that word before, is countable. I don't have any fractions of. If I'm talking about soda cans, I'm talking about a can of soda. Now, if you're talking about the contents of the soda, that's different. But if I'm talking about just cans of soda, and it doesn't make sense to cut the can into fractions. So we're going to count those as whole. I think the book talks about zip codes and things like that. So you never just take a zip code and cut it into fractions. It represents an area. So that would be more, actually that would be more qualitative in nature because it just provides a name to a city. But it is actually a number that can be counted. Discrete, and then we've got continuous. Continuous data, we're dealing with fractions. Fahrenheit temperature, I used that one a while ago, so that's a pretty good example. I can start chopping things into fractions, and then I can turn them into decimals, turn the decimals into fractions. Then we can turn fractions into percentages, decimals into percentages, things like that, so they make sense, to most people. Here's some variables here. So when we're dealing with variables, they can be all kinds of different type of variables. We have a recorded value. It's called raw data. Sometimes we want to put boundaries around those data, or these data. So, like this particular variable, we have a recorded value of 15 centimeters. So a boundary would be something like 15 centimeters, and then the next increment would probably be like 16 centimeters. And if you go the negative direction, you're going to go to a 14 centimeter. So I need to have a boundary somewhere. Usually we put the boundary in between the two numbers. So in this particular case, we've got 14.5 to 15.5 for a boundary for this particular value. Talk about Fahrenheit temperature again. We have 86 degrees, so we're going to create a boundary for that. It would be halfway in between the next recorded value. So 85%, 85%. So we see or degrees, I'm sorry. So 85.5 degrees to 86.5 degrees would be our boundary. And time, we can do the same thing. We've got 43 hundredths of a second, and then we can create a boundary for that, and we can go into a third decimal place, and we can record that value as a boundary for 43 one-hundredths of a second to 425 thousandths of a second to 435 thousandths of a second. So we can record those values as boundaries. And the boundary would include the actual value. So, and mass, we have grams of weight value. So I have 1.6 grams. So we can create a boundary, and we're going to be creating boundaries, and I'll show you how to create those boundaries mathematically when we get into frequency distributions. So the mass for this particular value would be 1.55 grams to 1.65 grams, and that will include the actual value. So that'll make a lot more sense when we get into the actual frequency distribution. Levels of measurement. This one's pretty important.